Welcome to my channel Living Linux. Now that we have Llama.cpp working on the CPU and on the GPU with Vulkan, I thought let's try to see what is faster on my AMD Ryzen 7 8845HS. Running Llama.cpp on the CPU, or is it faster with Llama Vulkan on the 870M integrated GPU. Now, when you're running with AMD or Intel, things are a lot easier. You don't have to build it yourself. You can just go to the releases and download the one that you need. So in my case, Ubuntu with Vulkan and just x64 on the CPU. So here you can see that I have the AMD Ryzen 7 8845HS with Radeon 780M GPU. Now to speed things up, I already did the Llama-bench. So just on the CPU. So those are the numbers. Almost 35 tokens per second for PP512 and 10 tokens per second for GG128. And I think that is where the bulk of the work is done with GG128. Now, when we run it with Vulkan on the GPU, you can see that PP512 is almost 5 times faster, but that's not where the bulk of the work is done. And with GG128, it's, let's just say, 35% faster. So from the benchmark, it should be faster on the GPU compared to the CPU, but as I said, the bulk of the work is done with GG128, so it's roughly 35% faster. So let's try it first on the CPU. And as you can see, 16 threads. That depending on your CPU, you have to play around with it to see what is fastest for you. So as a rule of fist, one thread per thread available on your CPU. So in my case, I have 8 cores, but they're able to run 2 threads at the same time, so 16 threads in total. And that's also what you can see here in the system monitor. So I'm testing with Llama 1.1, 7 billion parameter file. So you can download it from Hugging Face. So you need to have the GGUF. And we're going to do a small test, and that is also why I have the seconds available for the clock. So we can do like a rough estimate. So let's just wait for 0 seconds, and then we're going to ask the question. 0. And because I set 16 threads, you can see that they're all in use. And it's, let's just say 35 seconds, something like that. Now I don't know exactly how to interpret these statistics. Didn't always make sense to me, but like I said, 35 seconds. So let's go to the Vulkan version. Yeah. Let's now do the same thing. So we're going to wait for 0 seconds. And now that we're running it with Vulkan, this should mean that there's hardly any CPU load. So 0 seconds. So that was like 25 seconds. Yeah, the answer was a bit different than when we were just running it on the CPU, so it's not really apples to apples. But yeah, it was able to finish faster with Vulkan on the GPU. I've done some tests before, and every time it was faster on the GPU. And well, you might wonder, like, will it be faster with less threads? Because although all the cores were 100% active, so from that perspective you would say that memory access was not an issue. But from my test, yeah, let's go back to the CPU again. Let's see. No. Yep. So let's just do another test with 8 threads. So let's just start it on 30. So now you can see that it's only using 8 threads and doesn't look twice as slow to me. And it finished in around 30 seconds. So, like I said, for your own system, if you have a different chip than I have, yeah, just play around with the amount of threads if you're running it on the CPU. I didn't see much impact when running it with Vulkan, the amount of threads. But that also might be different with a different kind of GPU. So yeah, I think that both Intel and AMD, they're making a lot of progress with the performance of their integrated GPUs. So on my AMD 8845HS, Llama.cpp is faster on the GPU, even when you use 16 threads on the CPU. So I think for the future, with let's just say a lot of the high-end chips with integrated GPUs, when you have the high-end integrated GPU, yeah, then probably it will be faster on the GPU compared to the CPU. So this is all for now, and I hope to see you again in my next video.